I'm good at counting, apparently. Alrighty, y'all. We are still doing notes and stuff today. It's not a super ton of them. But we're going to keep going with our solving stuff that we started working with yesterday. So we're going to be working with simplifying and solving. We want to find out what x is. Or if we can. These ones we can't. We're just simplifying these. The solving is the next step. Sorry, I was looking at my notes, not the page. So we're just going to simplify these as much as we can. And you can, for some of them, remember we had a little shortcut where if your base of your argument and your base of your exponential are the same, they're inverse operations. Or you can switch them around from exponential form to logarithmic form. Because this is a base of e. So if we have log base e of something, we don't know what, equals whatever our exponent was. ln of x. Well, log base e, that's the same thing as ln of blank. That's a circle, not a zero. I just realized that looked like a zero. ln of blank equals ln of x. So what goes in that blank? X. E and log base e are inverse operations. So e to the natural log is just whatever that is. It's very, very similar on the next one, on the 10. We have a base 10. So this is log base 10 of something, we don't know what, equals that exponent, log 4. So what goes in the blank? 4. Base 10 and common log are inverse operations. So they undo each other. So if the base of your exponential and the base of your log are the same, love how much space I gave myself here. So much fun. I'm just gonna write it. What does this one equal? Then let's switch it around if we don't see it. Base 5, so we'll switch it to log form. Log base 5 of something equals, ooh, I gotta give myself more space than that. There we go. Whatever my exponent is. Whoa. Whatever my exponent is. Log base 5 of 27x. So what goes in that pink line? 27x. So if the base of your log and the base of your exponential are the same, they cancel each other out. They are inverses. Those two pieces cancel out, and we're just left with the 27x. We're going to do a lot of switching between exponential form and log form today while solving. Lots and lots and lots and lots and lots. Okay? So now we're asked to solve. We're going to get all the way to an x equals. I want to know what x is. So this says e to the x is 6. How can I get that x out of the exponent? Say it louder because I couldn't hear my ear. Put it in log form. So this becomes log base e of 6 equals x. We're using our BE equals A becomes log base B of A equals E. This guy. Bay. Y'all love the bay thing. That is an E. It's just tiny. That's not an eraser. There we go. Whoa. Sorry, my pen's being a jerk today. There we go. That's E for exponent, not E the number. That's why we usually use P, but you don't like your bay, so whatever. So back into our solving down here. Log base E, that's the same thing as ln of 6 equals x. That's our exact answer right there. ln of 6 is a number. It's not a pretty number, but it's a number. If we wanted to get a decimal answer, what does x about equal? What's an estimate? Say it louder. 1.79. Because we type ln of 6 in a calculator. Yeah, chill, bro. Okay. So then we're going to go with this one. Separate problem. Before I can switch it into log form, I need to have my exponential all by itself first. So what are we going to do first? Add 5. And we're going to get 4 to the 2x plus 3 equals 14. And then we're going to switch this around into log form. I'm just going to warn you, this one's going to look a little gross for a hot minute. Log base 4 of 14 equals our exponent of 2x plus 3. Switching it around in log form here. We want to get x by itself. So this left-hand side might get a little ugly, and that's okay. What do we need to do to get x by itself? What do I need to do to get x by itself over here? Subtract 3. So we're going to have log base 4 of 14 minus 3. Can I simplify that to 11? No. No.
Wait, what?
Log base 4 of 14 is not the same thing as log base 4 of 11. Logs, think of that, logs as an inverse of exponentials, right? Order of operations says we have to log it before we can subtract. Logs go with exponentials in our order of operations. So you cannot do subtraction before you do the log. It's a PEMDAS thing, but it's now PEMDAS. But logs don't come up often enough to toss logs in there when you learn PEMDAS. So logs are an inverse of exponentials, which puts them firmly in the E in PEMDAS. Okay, so do not simplify that part. We still need to get x by itself, so what are we going to do?
Are we going to divide?
Divide by what?
By 2?
By 2. And our exact answer is going to be not pretty. Because our exact answer is log base 4 of 14 minus 3 over 2. What if we need a decimal answer? Bless you. So this is our exact answer.
What did you ask?
What if I need a decimal answer?
Oh, yeah. Put it in the calculator.
Put it in the calculator, but I can't put log base 4 in a calculator. So we're gonna use, I saw you say it, but it didn't come, like, no sound came out. We're gonna use the change of base. So we need to rewrite this using either the common log or the natural log, because log base 4 is not a button on my calculator. What's up?
Why can't we leave this as the answer?
Because I need a decimal answer. What if I needed to go that many steps? Or I needed to go that many miles? Or my airplane was at that altitude? Because logarithms tend to be used a lot in aerospace engineering. Because it's a very real world, exists a lot in logarithms and exponentials. So if I need to know what altitude my plane is at, that doesn't actually tell me what my altitude is, because I have genuinely no idea what that is in a real number. So if we need an actual number, we have to use the change of base to do that. So we need to take this, just the log base 4 of 14, and put it through change of base, which I'm going to zoom this in more. So this was our exact answer. And it genuinely does not matter if we use common log or if we use the natural log. Does not matter even a little. Whichever button you like pressing better. None difference. I tend to write log, but if you want to write ln, as long as you make the same choice, numerator and denominator, it does not matter. Because what we're going to do is we are going to take that log base 4 of 14 and change it to log of my argument over the log of my base. Argument over base. Now that I can type in the calculator. Everybody else is still hanging out here. That's an X. Bad X, but it's an X. It's very ugly. Super ugly. I agree with you. These are ugly. But that is something I can type in the calculator. And we will do that together because it looks surprisingly worse in a calculator.
Yeah.
So we're going to type in the calculator. And if you're using one of my lovely yellow calculators, it has one of my most favorite buttons in the entire world. Second column, third button down, makes a fraction. And it looks like a fraction. But I needed a fraction in my numerator, so I can actually hit that button again. And we can put in log of 14 over log, oh, nope, make the same choice each time. Log of 4. Hit the right arrow to get out of that fraction within the fraction. Minus 3 over 2. Pulling that up from memory. I think I used all the right numbers. So it looks shockingly even grosser in calculator font. But the calculator will do all the heavy lifting for us. Okay, so maybe it's not altitude, maybe it's the depth of my submarine. Because it's negative 0.548. That's probably bad if that's the altitude on my airplane. I'm going to go with let's not ride that airplane. Okay, but that gives us x about equals negative 0.548. That's called I put it into context without looking at the actual answer. Okay? So our solutions can look super gross. let's do,
With the angle there?
yep, let's do, I was gonna say, let's do one more for sure and see if we can fit a second one in. Cause now that, what's up? Okay. Very long. All right. This one is the same thing, different flavor. Like it's the same process, different numbers. We need to get our exponential by itself first. So what's my first step? Subtract 5. And we have 10 to the 3x minus 1 equals 25. Switch this around into log form, and my screen just freaked out on me. There we go. And we're going to have log base 10 of 25 equals 3x minus 1.
Are you gonna add 1 on both sides?
Not add 10 on both sides.
No, not 10, 1.
Add 1. Yeah. Sorry. I heard 10. Whether or not we said it that way, I don't know. Sometimes I'm just old and my ears don't work right. Log base 10. Do I need to write the 10 there? No, it's already in common log, so we're not even going to need to use change of base. It's already a button on the calculator. My favoriteest thing in the whole wide world. Log of 25 plus 1 equals 3x. How do I get x by itself? Divide by 3, and we have log of 25. Then minus plus 1, all divided by 3. So what is the approximate decimal answer for x? Yes, because log base 10 is the common log. Log base e turns into the natural log. Log base 10 is common log. So what's our approximate decimal answer? 0.799. On this right-hand one, what are we going to need to do? Divide by 3. Option B is you could make it x cubed, but why make your life harder than have to cube root stuff? No. Divide both sides by 3. That is the benefit of log properties, is I can take those exponents, make them coefficients, and then play with them like regular numbers. This is the last one we're doing today for sure. So divide both sides by 3, we get log base 2 of x equals 7. What can I do now? Switch to exponential. So it's going to be what? Talk me through it. 2 to the power of 7 equals x. So what does x equal? Yeah. So we're going to need to be able to switch both directions, both from logs to exponentials, from exponentials to logs, using change of base. There's a couple on there on the homework for 6 that are that look really complicated, and if you see that, don't freak out. We'll do the hard ones on Monday. Okay, so if you see one and you go, huh, save it for Monday.
So is 5, 6 due Monday then, or Tuesday?
No, Tuesday. Because we still have notes to do, because there's...
Apparently my 5-3 is missing. I did that with 5-2.
Okay. I'll mark it. It's just called I didn't read the label right. Oh, I have it marked in here. It just didn't save in the grade book.
Yeah, because it just said I was missing. I was like, oh god.
Okay. Skyward's been doing that to me lately. I've had like whole colors of stuff not go through. That's why I mark in different colors so I know which day I did it. But for some reason, there was like a whole set that Skyward didn't save. So I'll have to go check the pink stuff.
Yep, thanks.
Got it. It's in now. Have a great rest of your day. Have a good weekend. See you Monday. Bye. It's in there now, Henry.
Thank you.
Child.
Sorry, I always just keep forgetting.
That's what I got. That's all I got.
Thanks.
I like your shirt.
Thank you. I made it. There are, in fact, 8 laws in the song. I counted.